Hey LPS students, so this will be the second part of the matrix video. In this video we are going to define all the functions that we declared with the proper return values in our header file. So even though I have all of the functions written out here, you don't need to have them written out right now. Just have a matrix.cpp file with the right headers. So we'll start with doing our default constructor, and then our other constructor that takes in an int rows and columns argument. So first and foremost, so both of these constructors, they will build a two-dimensional floating a two-dimensional float array. The only difference is this one builds it with 0, 0 dimensions, and this one will build it with rows and columns dimensions. So instead of having building the 2D array in both these constructors, what I'm going to have them do is I'm going to have both of these constructors call this third function in the matrix class, which is going to be called allocate, so alloc for short, and it will take in int rows and int calls. And so both of these constructors will call this function, and this means we just have to write the code only once in here as opposed to twice in both the constructors. So what would the constructors do then? They will call the alloc function, which returns a pointer to a pointer for floats. And what we'll do in our first constructor is we will assign the matrix variable that we declared in our class file in matrix, the implementation file. We declared a floating pointer to a pointer for matrix, and we'll assign that here to a call to alloc with how many rows and how many columns? Well, 0 rows and 0 columns. Great. So, and then what we will do in the matrix function is we will call alloc, we'll assign matrix to the alloc of rows and calls. Also, one other thing we should do is we have these properties x and y for any matrix, and what we want to do is we'll want to store in here, we'll say x equals rows, y equals calls. So as we call the alloc function, we'll assign those two properties to, so the rows to x and calls to y. All right, so what else do we do in the alloc function? So we will want to declare a new floating point matrix called new matrix, and inside we will put a float of however many rows we'd like. So this is similar to this example here, where we create a array, a pointer to a pointer for a 2D array, and then assign it to however many rows we want. So we create rows amount of pointers. Each of those will point to a new array. Great. And then what we will do is we want to create a for loop for however many rows we have. So for int row starting at 0, while row is less than however many rows we have here, we will add 1 to the row, And then what we'll do is for each pointer, we will create a new float array of however many columns were specified. So inside of each one of these pointers, we'll point to an floating point array of however many columns we passed in. All right, and then once this process is complete, we will have created a matrix of rows, columns, a 2D matrix, and we'll want to return that new matrix. And so if you're confused about this new matrix ordeal, what is happening is we return this variable and it gets assigned to the matrix object. So when we call alloc, it will assign it to the matrix. It will assign it to that matrix because we're returning this double pointer. Okay, so let's do another tricky function, which is how do we resize the matrix? So we'll eventually get to some of these other functions, but the next function we can write is the SetSize function. Okay, so one of the assumptions for this function is that when we receive rows and columns argument for this function, we're assuming that rows and columns are larger than our older values. So what that just means is we only want to create a new matrix for when we're setting a new size if the new size that's provided is larger than whatever original size we made when we built the matrix. So basically the first thing we're going to want to do is we need to check to see if rows is larger than what value. They're going to want to inspect this X property and this Y property. So we first check to see if rows is larger than X and calls is larger than Y. So use an if statement. If rows is, and we'll type literally that, if rows is larger than X and calls is larger than Y. All right, so if this is true, we can build a new matrix and return that matrix. So we already built a function that will create a matrix of int rows and calls, and it's called alloc. So what we can do here is we can just call the alloc function with rows calls as arguments. And this will build a new matrix. So what we want to do is we want to declare it, float double pointer, we can call it new matrix again, and then set it equal to whatever alloc will build for us and return as new matrix. And the next goal is that we need to if we're building a new matrix, we need to deallocate the memory of the old matrix. So one thing also that I forgot to do is, so we need to do two more things. So we built this new matrix, and the other requirement, I believe, was we needed to copy the elements of the old matrix into the new matrix. Okay, so we'll do that, and then we can release the memory of the old matrix since we don't need that anymore. Okay, so those are the two things. I was forgetting what what else we needed to do for this function. So the next thing is we need to fill new matrix with the elements from matrix, the original matrix. And what we can do is we'll use a for loop and we'll iterate over the size of the old matrix. We'll iterate over the size of the new matrix, which is larger, and then just fill it with whatever element from the old matrix. So we'll create a for loop, and we'll say from int I equals 0, while I is less than rows I++. And what we'll do is we will set the new matrix, the pointer here, at I to equal a whatever is at matrix of I. So what that will do is it will copy all the pointers from the rows in the old matrix to the new matrix. So it will basically copy all these pointers into the new matrix. And all those pointers will still refer to all the same elements in memory as the original matrix. So finally, what we can do is, once we're done with this, we can release memory for the old matrix, and we're going to call the a function that we're going to create next, which is called dalloc. So we made this function called alloc that builds us a matrix. Dalloc will release memory from the matrix. And in the destructor function, we're going to just call dalloc. So there are multiple points where we need to deallocate memory. So we'll call it here as well. Great. And then finally, what we'll do is we return the new matrix. So that's if the size is larger than whatever our old matrix is. Let's deal with the condition where it's not a larger matrix. So if the user passes in sizes that are that are not larger than the original matrix, we can just return the original matrix. Cool. So the next thing we need to do is we need to work on releasing memory from the old matrix. So we will make this dalloc function inside of the matrix class, and the goal of this function is to delete the elements that are stored in matrix. So what we can do is we can iterate through the rows of the original matrix by saying for int row equals 0, and while row is less than x, we will add 1 to row. So, and then if we access matrix at row, this will point to the array of floating point elements, and we can release those now. So this basically got us to here, and we want to release these because they are now copied into the new array. All right, so the way we will do that is we need to use this delete method. So delete with 2 brackets, and we're going to delete the elements that are pointed to at all of the row pointers. So we're deleting everything that's stored in each one of the columns for the old matrix. And once we've deallocated those elements, we can delete the original pointer at the matrix. All right, great. So that is the dealloc function, which will be called in our destructor function as well. Great. So finally, we have 3 more functions to program, and they're all just returning pointers to certain either a row element or a column element or just the beginning of the matrix. So these are all pretty simple. So we will create a float pointer variable, and we'll say float start, so the start of this entire 2D array. So basically, we're going to want to return this pointer, and we can do that by getting the matrix at 0. So that will return this pointer right here. And then we can return the start. So now we have that pointer. Whereas the getRow function will want to return one of these pointers, whichever pointers is specified, whichever number for the row the user wants, we will obey. So what we're going to do is first we will, okay, so this, one thing that's important here is we want to first check to see if this value exists. Like, let's say we only have 5 rows and the user's saying, give me the 7th row. We want to tell the user that's out of bounds. So we'll say, we'll do just a sanity check really quick. If the row, sorry, if so really quickly, I'm going to change this to row and then change this to column. And we're going to check to see if this value that the user passes in, if row is larger than x, so that x is basically the variable that's going to store the size of any individual matrix. So we're going to see if the value that the user is passing in is larger than x. And if that is the case, we want to send in a message that essentially just says error, the row at index, and we'll say whatever they passed in is out of bounds. Okay, and then if it passes the sanity check where it is in bounds, we can return a float pointer, and we can call this row index, and this will be whichever pointer is in this array of pointers. So we'll say matrix at row. And then finally, we need to return the row index variable. All right, last function to program, get column. So we're going to do something similar where we first check to see if the columns is within bounds. So what I'm going to do is literally just copy this code and then change this up a bit. We're doing columns this time. So we're seeing if the column is larger than the size. So if the column at index col is out of bounds, otherwise we will return a pointer to the column at 0y. So how do we access this value? So we want to pass in the address for the actual float that is stored, let's say at 0 index 2 right here. And since the column values, they contain actual floating point numbers as opposed to you know, our row array, which is just float pointers. So in order to return a pointer, we're going to need to use this reference variable, the ampersand. And we will say ampersand matrix at 0, comma, y. And that will return the memory address of whatever value is stored in the index of the first row array. All right, so this concludes writing all of the functions for the matrix class. The last thing we need to do is we need to run a few tests, and that will be part 3, where we basically test good test coverage in the matrix test driver, where we're testing all these conditions. So stay tuned for that part, and this is the end of part 2.